Have you ever wondered how we learn a new skill, like riding a bike or playing a video game? It often comes down to trying something, seeing what happens, and then adjusting our approach. This fundamental process of trial and error is not just a human trait. It's the very core of one of the most exciting fields in artificial intelligence: reinforcement learning. Imagine you're in a park with your dog, Sparky. You throw a ball, and when Sparky brings it back, you give him a treat. The treat is a reward, reinforcing the action of fetching. In this simple interaction, you're using the basic principle of reinforcement learning. You're teaching an agent, your dog, to perform a desired action by providing positive feedback. This simple idea of learning through rewards and consequences is what allows machines to master incredibly complex tasks, all on their own. To truly understand how this works, let's break down the key components. In the world of reinforcement learning, or RL, we have a few core terms. First is the agent. This is our learner, the entity we want to teach. Think of it as a robot, which we'll call Unit 734. The agent exists within an environment, which is the world it interacts with. For Unit 734, this could be a digital maze it needs to solve. Within this environment, the agent can perform various actions, like moving forward, turning left, or turning right. The most crucial piece of the puzzle is the reward. Whenever the agent performs an action, the environment gives it feedback in the form of a reward or a penalty. A correct move, one that gets it closer to the goal, might earn it a +1 point. But an incorrect move, like bumping into a wall, results in a penalty, a -1 point. The agent's single driving goal is to maximize its total cumulative reward over time. So, how does the agent actually learn? It's a fascinating process of exploration and refinement. When we first place Unit 734 into the maze, it has no idea what to do. It starts by making completely random moves, stumbling around, and frequently hitting walls. Each collision gives it a negative reward, teaching it which actions to avoid in certain situations. Slowly, through thousands, or even millions of these trials, it begins to build a policy, a strategy for choosing the best action in any given state. This learning process involves a delicate balance. The agent must engage in exploration, trying out new, random paths to see if they might lead to a better reward. At the same time, it needs to practice exploitation, using the knowledge it has already gained to follow the paths it knows are good. Over time, as it explores the maze and exploits its knowledge, Unit 734's random stumbling transforms into an efficient, optimal path straight to the goal. This powerful learning framework isn't just for teaching robots to solve mazes, it's already changing the world around us. The principles of reinforcement learning are the driving force behind the sophisticated AI in self-driving cars, which learn to navigate complex traffic scenarios by being rewarded for safe and efficient driving. It's the magic that allows AI to defeat the world's best players in complex games like chess and Go, discovering strategies that human masters had never even considered. When you browse an e-commerce site and see recommendations that feel perfectly tailored to you, that's often an RL system at work, learning your preferences to maximize the chances of a successful purchase. From optimizing logistics in vast supply chains to discovering new drug compounds, reinforcement learning is pushing the boundaries of what's possible. As we move forward, this ability for machines to learn from experience will undoubtedly unlock solutions to some of humanity's most complex and challenging problems.